So, today I want to do another very important test with these three big glasses. Because there is one very important thing that Elon Musk has said and keeps repeating is that engineers have a tendency to optimize something that should not be here. And now let me explain. So, in my machine I have these stepper motors that are moving the glass forward to be filled, right? I have kept optimizing this motor in two ways. First, I switched to other drivers that are more silent, smoother, make less noise. And the second step which is coming now is sensorless homing with this motor so that I can use the feature of the driver that tells me when it's blocked, stalling, and that will tell me that I have hit an end stop, and I can use this as a zero reference for my movement. So this is all optimizing this motor. But listening to what Elon Musk says is, do we even need this motor? Because if we can completely drop it, if we can get rid of it, everything will be easier. I mean, we don't have the wires, we don't have a driver, we don't have anything anymore. How do I find out if this motor is needed or not? Now, looking back to down here to my beer filling machine, we have a left and a right conveyor. And we have way too many hoses lying around here, blocking everything. Let's get rid of these first. So, this is basically my system I have here. Well, if you're familiar to the channel, you know that thing already, right? And now if I put the glass here. Oh. See? Something nasty happened here. Now it's moving again. So, another lesson learned right now, beer becomes very sticky when it dries, and so it blocked everything, but with just a little bit of nudging it, I could get it back to move. So we have left and right these two conveyors. And so we have two motors, one is here and one is here. These two motors, and originally in the theory, I calculated that one should be enough to move a full and an empty glass of these. But since paper is patient, I was like, I'd like to go on the safe side. That's why I put in two motors to make sure it works. But that could lead me down the path that I will keep using two motors even if one would do the job, because you don't realize if something is too big in most cases. That's why engineers have that nasty tendency to add some margin on top just to make sure it works, and in the end you end up with a bloated construction and nobody even notices. I mean, I understand the engineer over-dimensioning stuff because nobody will complain, nobody will punish him for having over-dimensioned the stuff, but they will punish him if he under-dimension it and it breaks and it doesn't work anymore. Now, to the experiment. First thing will be to take this cover off and unplug one of these two motors. And then I have only one motor running, which the software will not notice if I properly reference it. So I need to do the referencing, but after that it's gonna be fine. Actually, yeah, I could finish the cycle here. Okay, so, and then I can reference it, and as I know my software, it will not notice that only one motor is running, and it will move, and then we can check how much force do we have moving. First step is to take things apart. 3 screws on this side. 1, 2, and 3 screws on this side. Now it's over. If you play around with stepper motors and drivers, always disconnect power before connecting or disconnecting motors, or you will have a chance to fry the drivers, which you usually don't want to do. So, where is what? Everything is small, my eyes get old. So I need my reading glasses for this. So which one was what? It's so badly written. Where is my cell screen here? Light. So that is motor L. Okay, take that one out. And we have one of both motors deactivated. Power that whole thing up again. And now we have only one moving. That is actually exactly what I wanted. I accidentally disconnected the valve motor. That confused me a little bit because usually the valve closes as a first step in my program. I didn't hear that. But we don't care about the valve now. We do care. It's about glasses. Let's get some water. 2 full ones, which is actually more than what we wanted to move. But now that I'm testing, I'm really testing to the limits. So what did we say? We had originally the idea is to move 1 full glass and 1 empty one. Yeah, that's it. But so if I want to push out 1 glass out of the machine, and I have 2 full ones and 1 empty one. So what happens if I put this thing here? It gets moved. Okay, but it gets pushed out to the side over here. But that's unfortunate. But oh no, what we could do is do a hack. Maybe add some kind of guide rail over here to make sure it stays where it should. Guide rail. Ruler size. That sounds good. Let's add that ruler over here. So it will kind of keep the stuff from falling off. Now, number 2. Now it gets really tricky. Look at this. Oh. Yeah, right. Right. Now, to test this, I need to go into another mode. Reload the web interface. So we want to check this case. Now I'm curious. Yeah, what happens? Voila! Okay. Luckily it's a GoPro, so it's water resistant. I nearly drowned the GoPro with 1 liter of water. But still, I can, with 1 motor, move 2 full glasses and 1 empty one, using that 20-tooth pulley and that 2mm belt. I mean, with the GT2 belt means having 2mm tooth distance. I mean, you see, it's a tiny belt here, right? With that cute little belt and that cute little pulley, I can move everything. So, since I'm thinking about the next machine, imagine I can build the whole thing just with 1 conveyor motor instead of 2. And it definitely seems doable. That's amazing. This is an amazing insight to know I can move all these glasses, all that weight with just 1 motor instead of 2. I mean, imagine the cost savings, the mechanics. I mean, just adding 2 motors is mechanically complicated. So, full success. That's also why I still say, if whatever you have in your mind, just do it. Because I have done this machine. And many things of that machine are not perfect. But now that I have this machine, even if I might have to throw it away, I have that test stand where I can test under realistic conditions how much force do my motors have. That's not something you can do with pen and paper. Or you can do it, but you're never going to be sure. Now I am sure I can move 2 full and 1 empty glass at once with just 1 motor, because I have tested it and I know now how the friction behaves between PETG 3D printed material and the glass bottom of this. I mean, if you want to calculate it, it's very complicated and you need to basically do tests to test all the variables of your calculation to make sure that your whole calculation works. Instead, you just do a test of the whole thing. And that's why you should do it. Whatever you do, you will learn. Unless you... no exceptions. There are exceptions, but I don't guess there don't think they are watching my channel. So that's the key thing. So I'm very happy I've built that thing. I'm very happy I came to that insight. And now I can go back to the drawing board and make everything leaner and easier. And having just one conveyor will make that I push the glass slightly to the side, which is also very good. I have my new favorite sensors here. That thing here is actually an optical sensor that does infrared reflection, so it shoots out an infrared beam, and if it sees infrared coming back, it will detect if something is on front of this sensor or not. That is very useful because in the past here I had these mechanical switches down here to detect if a glass is here or not, but these are not so reliable, especially this one here. Oh, yeah, of course. These sensors down here, they don't work very well with very light plastic cups like this one. Plastic cup like this is too light, so you barely can detect it. You see, that one doesn't even get detected because I need some force. But this one would detect it. But it's a bit dependent on the distance, and you can adjust. Here you see the little adjustment screws. So you can adjust the distance. But if I push all the glasses to one side, and I have my sensor over there, then it's great because I will always have the glass close to my sensor and I can set my distance once, and that sensor will easily detect. It's becoming more and more asymmetrical, but that's not the big issue. So yeah, that's the direction we go with the new machine, and I'll show you more on CAD as soon as I have it.